Okay, then let me start today's class. Today we will discuss the mean, variance, and Poisson distribution. In the previous class, we have discussed and Poisson distribution is what? Something that we the discrete probability distribution in which n is very large and tends to infinity, and p is what? P, the probability is very small. Okay, and PMF, that means probability mass function is what? The P of x equals to R equals to e to the power minus m to the power r divided by r factorial, where m is what? M is the parameter of the distribution. And remember one thing that in Poisson distribution, we use only one parameter. And the Poisson distribution can be so as the limit in case of binomial distribution. Okay. Now let me discuss about mean and variance of Poisson distribution. Mean is what? Mean is this is the expected value. Therefore, to find the mean, we use the definition of expectation. Okay, and see that the PMF of probability distribution is what? E to the power minus m to the power divided by r factorial. Here, mean is what? Summation xi into pi. when uh, when suppose the distribution is we consider the discrete probability distribution, then expectation is defined like as summation xi into pi, where p is what? P is the probability of xi, pi is the probability of xi, and if x is a discrete random variable, then expectation can be defined as summation of xi into pxi. Here p is what? P is the probability. That means in place of P, we put the probability mass function of this distribution. And probability mass function of this distribution is what? E to the power minus m to the power r divided by r factorial. Okay? And using the definition of expectation, we can find that mean is what? Mean is m. Okay? There's some calculation. See that this one is summation xi into pxi. Here x takes the value, I takes the value 0 to n. Therefore, it is come as p1 x1 plus p2 x2 and so on. And here see that if you suppose this one x equals to 0, then what we get? We get I equals to actually 0. Then what? Here we get e to the power minus m. The second case for that means p2 x2, we get 1 into e to the power minus m. After the calculation, we get mean is what? Mean is m. Okay. See the calculation part. Similarly, next we can define variance of Poisson distribution. By the definition of variance, what we get? Variance of x. When x is a discrete random variable, variance of x is what? The expectation of x square minus expectation of x whole square. Okay, expectation of x square, that is what? Summation of xi square into pi. Square is not used in p. Okay, remember this thing. Expectation of x square is always what? Summation of x square into p1. That means suppose if we is summation of I from 1 to n, then we write xi square into pi. We don't use the power in p. Then summation of xi square into pi. For that case, we write 0 into e to the power minus m, 1 into m into e to the power minus m, and so on. And mu square, here write suppose the summation of xi square minus pi square minus expectation of x whole square. Expectation of x is what? Expectation of x is nothing but mean, and mean is mu. The letter mu is used to denote mean. Therefore, here it is write as summation of xi square into pi minus mu square. Mu is what? Mu is the mean, and we already get the mean of the Poisson distribution is what? M. Okay, therefore, see that the some calculation part we get variance is also M. Note that uh, expectation and variance of Poisson distribution is same. It is nothing but it is M. But in case of binomial distribution, mean is what? Mean is NP and variance is what? NPQ. Okay. But in case of Poisson distribution, mean and variance are same. Note down this one. Mean and variance of Poisson distribution is always M. And standard deviation is what? Standard deviation is the positive square root of variance. Therefore, from this one, we get standard deviation of Poisson distribution is what? Root over M. In some books, it is write as lambda. Yesterday, I have told you that in some books, probability mass function of Poisson distribution is defined as e to the power minus lambda to the power r divided by r factor. In that case, lambda is what? Lambda is the parameter. Here we use in place of lambda we use m. Both are same, but these are the parameter of the distribution. If that parameter of the distribution considered as lambda, then what we get? Mean and variance of the distribution will be lambda. These are same. And if we write the parameter of the distribution is m, then it is look like as m. This is the mean and variance of Poisson distribution is, remember that thing that mean and variance of Poisson distribution is same. This is m, or you can write as lambda also. And standard deviation is what? If we consider variance is n, then what we get? Standard deviation will be root over n. Okay. Let me give the recurrence formula for Poisson distribution. Yesterday we have discussed about the recurrence equation for binomial distribution. Recurrence formula, that is what recurrence formula is used to find the value of, suppose we are given the value of probability of x equals to 0. Then using recurrence formula, we can easily find the value of p of, that is probability of x equals to 1, probability of x equals to 2, and probability of x equals to 3, and so on. For that purpose, the recurrence formula is used. Okay. If suppose the probability of x equals to 0 given, then using recurrence formula, you can easily find the value of probability of x equals to 1, probability of x equals to 2, and so on. And here also see that the P of R. P of R is the probability of mass function of Poisson distribution. It's minus lambda to R divided by R factor. And to find the recurrence formula, uh, we uh, we uh, we have find the value of p of x equals to r plus 1. Okay, p of x equals to r. These are given. This is the probability mass function. This is what? This is e to the power minus m into m to the power r divided by r factor. Therefore, putting the value of r plus 1 in place of r, we get p of x equals to r plus 1. And p of x equals to r plus 1 is what? E to the power minus m to m to the power r plus 1 divided by r plus 1. Okay. And by dividing these two equations, what we get? The p of r plus 1 divided by r plus 1 is what? After calculating, we get p of x equals to r plus 1 is what? M divided by r plus 1 into pr. Here r takes the value from 0, 1, 2, 3 up to so on. Okay, this is the required form, recurrence formula of Poisson distribution. And yesterday we have discussed about recurrence formula for binomial distribution. In case of binomial distribution, it is look like as what? Yeah, this one is the n minus r divided by r plus 1 into p by q divided by p of r. And notice that here r takes the value from 0, 1, 2, 3, 4 up shown. But in here r is taken from 1 to 4 up to 2. Okay, if suppose the x equals to 0, means if r equals to 0 are given, then using this formula we can easily find the value of e of x equals to 1. If you put suppose r equals to 0, then the left hand side we get which one will be p of x equals to 1. And if suppose p of x equals to 0 is given, then it is easy to find the value of p of x equals to 1. Okay, is there any confusion? Hello?
No, ma'am. No, ma'am.
Just remember the formula and remember the mean and variance of Poisson distribution. Okay, because in suppose multiple size question, some question can be arise like suppose mean and suppose variance of Poisson distribution are first option is suppose same, second option is both are not equal. Suppose one is suppose n and other is suppose NPQ. Okay, then option is correct option is what these are same. Suppose these are equal. Okay, remember that one. That mean and variance of Poisson distribution are same. That is m. Okay, let me discuss some problem related to Poisson distribution. Take the first problem like this. The number of telephone calls arriving on an internet switchboard of an office is 90 per hour. Find the probability that at most 1 to 3 calls in a minute on the board arrival. Here e to the power suppose e to the power minus 1.5 are given. We are given the value of e to the power minus 1.5. Here see that the problem says that the number of telephone calls arriving on an internet switchboard of an office is 90 per hour. 90 per hour. Means the mean is what? 90 divided by 60. Okay? 90 divided by 60. It will be 1.5. That means what? 1.5 means what? It is very small. Therefore, from that one, we say that X follows Poisson distribution. Okay. In Poisson's case, the condition is what? When we use Poisson distribution, when n is very large, probability is very small, in that situation, we use Poisson distribution. You see that m is what mean is what 1.5, very small, therefore we use Poisson distribution. Okay, and we are asking to find the probability that at most 1 to 3. See the word at most 1 to 3. At most 1 to 3 means what? It is start from 1 up to 3. Okay. Therefore, the required probability will be what? P of 1, that is P of x equals to 1 plus P of x equals to 2 plus P of x equals to 3. Okay. You therefore using just use the definition of Poisson distribution. That means use the probability mass function of Poisson distribution. You can easily find the value of P of x equals to 1 and P of x equals to 2 and P of x equals to 3 also. You see that the P of x equals to 1. If we take x equals to 1, that means here R is what? R is 1. Therefore, we write e to the power minus 1.5 R. M to the power R means what? 1.5 to the power 1 divided by 1. And we are already given that the value of e to the power minus 1.5 is what? It is 0.223. Okay? And this value is this one. And similarly, you can find the value of p of x equals to 2. Thus, put the value of r in place of put the value of r equals to 2 in the definition. Because the definition what we get the definition like a system. Power minus m x to the power r divided by r. Okay. And suppose the this problem is given, suppose like that one. Find the probability that at least three. Suppose at least three. Then what you do? Suppose in this problem, they are given find the probability that at most to three. Okay, at most 1 to 3 means the what the it is maximum three. Okay, at most 1 to 3 is maximum three. Therefore, we start from 1, 2, 3, and we stop at 3 because given that at most 3. Suppose you are asking to find the probability that at least 3. Then what you do?
তিনিৰ পৰা ষ্টাৰ্ট কৰিলো হয়, 3 পৰা।
3, 4, 5. Okay.
Yes, ma'am.
But here notice that it is not here we are not given the value of exact. Okay. In that problem, see that the is there is there any n? See the problem. It's not clarify the value of n. What is n? Means a number of tries. Number of tries are not given. Therefore, what you do in that situation? At least 3 means the what? We start from 3, 4, 5, and so on. Okay? Hello?
Yes, ma'am.
Okay. It's suppose the at least 3. If we start 3, 4, 5 up to n. But the value of n is not given in the problem properly. Okay? Therefore, we know that tell probability is always 1. Okay? Tell probability is always 1. Therefore, we find the value of suppose at least 3 like as suppose 1 minus at least 1 minus at most. Okay? 1 minus at least p of 1 plus p of. Okay? Are you understand?
Yes, ma'am.
Suppose
Yes.
your opinion is also correct. Suppose the at least but it starts from 4, 5 up to so on. But here the value of n is not given where properly the value of n is not given. Okay? Therefore, what do we do in that situation? That situation we always know that the total probability is always 1. Okay? Therefore, find the value of at least 3 with us the subtract the value of b of x equals to 1 plus b of x plus b of x equals to from 1. Okay, because the total probability is always 1, find the value of x is 3 with thus find the value of 1 minus b of x equals to 1 plus b. Okay. Here also first, you have to find the probability of x equals to 1. And similar, next step, you have to find the probability of x equals to 2 and p of x equals to 3. After finding the probability, just get all the terms. Okay, to get the required probability. Let's see the next problem. That if the variance of the Poisson distribution is 2, the variance of the Poisson distribution is 2, find the probabilities for r equals to 1, 4, and 4 from the recurrence relation of the Poisson. Also find the value of x greater or equals to 4. Okay. Here you are asking to find the value of p of x equals to 1, p of x equals to 2, p of x equals to 3, and p of x equals to 4 from the recurrence. So it's not meant from the recurrence relation, it's not meant. Yeah. But in that situation, if you are asking to find the value of x equals to 1, x equals to 2, x equals to 4, then you can use the recurrence form. Because recurrence form uh, indeed this formula is help us easily to find the value of x equals to 1, x equals to 2, okay? Suppose this is not mentioned properly. It has not mentioned in the recurrence formula. In that situation, uh, you can use recurrence because recurrence is very helpful to find the value of like is it to find the value of that one. Okay. Here see that the variance of the Poisson distribution is 2. Variance of the Poisson distribution is 1. Variance is defined as like as m. Okay. Yeah. We know that variance of Poisson distribution is m. M are given. Variance means in case of Poisson distribution variance is same. So the variance is 2, but we are given the value of m. Okay. Can you guess it? So, hello.
Yes, ma'am.
Can you guess it? Suppose you are given, suppose it like it's the mean of the Poisson distribution. Then we need to because we know that mean and variance of Poisson distribution are same. Therefore, if suppose given variance is given, then it we write as m. Okay. Then suppose m equals and either step to find the value of x equals to 1. X equals to 1. And in recurrence formula, one to find the value of 1. We have we need the value of x equals to 0. Okay? Because from recurrence formula, what we say? Recurrence formula gives that. So of r equals to 1 equals m divided by r plus 1 of r. R takes the value 0, 1. If suppose you are asking to find the value of x equals to 1. Okay? Get the value of x equals to 1. We must have the r equals to 1, r equals to 0. Okay? Are you understand?
Yes, ma'am.
Suppose you are asking to find the value of x equals to 1. Okay? Then what do we do? If we interested to find the value of x equals to 1, then you must have to put r equals to what? R equals to what? Suppose you are interested to find the value of x equals to 1. Okay? Can you guess it? Hello?
Yes, ma'am.
Yes, ma'am.
Suppose you are interested in the value of x equals to 1. Okay? Okay. Then in that situation, what do you put r equals to what? Tell me if we want to find the value of x equals to 1, then what we do? R in that situation r equals to what? Array, it is very easy. If you are interested to, are you listening or not? Hello?
Yes, ma'am.
Are you listening?
Yes, ma'am.
Then tell me if suppose we are in the value of x equals to 1. In that situation, what we put r equals to R, but we put the value of R. Then R equals
1.
how is 1? Here see that E equals to R plus 1, X equals to R plus 1. Okay? We interested to find the value of X equals to 1. They are given the value of X equals to R plus 1. Okay? Hello?
Yes, ma'am.
Interested to find the value of X equals to 1. Okay?
Yes, ma'am.
That situation, the value of R will be what? It is very easy. R equals to 0. If we put R must be 0. If R is,
Oh, yes.
it will be what? 1 plus 1 will be?
2.
2.
1 plus 1 is 2. But we are interested to find the value of R. X equals to 1. Equals to 1. That means what? R must be,
Oh, 0.
R must be 0.
0.
R must be 0. Suppose you are interested to find the value of X equals to 2. X equals to 2. In that situation, R is what? R is
1, ma'am.
R is 1. Suppose we are interested to find the value of X equals to 3. In that situation, R is what?
2.
R is 2. Okay?
Yes, ma'am.
Yes, in this problem, we are interested to find the value from 1, 2, 3, and 4. Okay? 1, 2, 3, and 4. First, put 1 to find the 1.
নিগুনটো লাগে যা নিগুনটো লাগে যা নহ'লে পলাব
Use X equals to 1. Okay? Suppose X equals to 1, then yes, R must be what? R must be 0. Therefore, at the step we find X equals to 0. Okay? Your X equals to what? E to the power minus M. Power minus M. Here M is what? 2. Power minus M. M to the power R. M to the power R. Here R is what? R is 0 divided by R factorial. R factorial is what? 0 factorial. 0 factorial is what? Value is 0 factorial is
0
no 0 factorial
1.
is always 1.
1.
1 1
Factorial all are
1.
okay. Here form we use as the formula. Use the formula x equals to what? X equals to 0. Then from the definition, what we get? Your x equals to R is what? E to the power minus M to the power R divided by R factorial. M is what? M is 2 minus M is 2 divided by R factorial. Power minus M divided by sorry, e to the power minus M then M to the power R divided by R factorial. Okay. First, find the value of P of x equals to 0. After that, find the value of x equals to 1. The recurrence formula actually P of x equals to R plus 1, but M divided by R plus 1, P of R. For P of R, in the value of 0, 1, and 3, and we get first find P of x equals to 1. Okay. Similarly, P of x equals to what? P of x equals to That means what? If we get p of x equals to 2, what we get is that to find the value of x equals to 2, we must put r equals to 1. Okay? Therefore, this one is 2 by 2 into p of t into 1. Okay? Any problem? Any doubt? Any problem? Hello? Hello?
No, ma'am.
Yes, ma'am. No doubt.
Understand properly.
Yes, ma'am. No doubt.
There any confusion?
No, ma'am.
মই অকল কৈ থকাবিলাক এনেই কৈ আছো আৰু ভালকে শুনাই নাই বাট আছে নেকি নাই then tell me how can we find the value of this one p of x greater or equals to 4 I have already say that trick of like that problem in the previous session. How can we find the value of suppose p of x greater or equals to 4? I have already told you the trick. How can we find the value of p of x greater or equals to 4? Hello?
Yes, ma'am.
How can you find the value of p of x greater or equals to 4? The previous class also we have discussed like that of problem, like that. Remember one thing that if suppose greater than equals symbols are coming in probability, always remember that thing. Then you have to find, easily find this is 1 minus p of x base equals to 4. Okay, remember that thing. Suppose here you are given to find p of x greater or equals to 4. In the probability when greater than equals to symbols are arrived, then always remember that you can easily find that the value will be like what 1 minus p of x base equals to 4. Okay? Understand? In probability when greater than equals to symbol is arise, then what we do, we can easily find that particular value that 1 minus p is equals to that number. Okay? The trick also. Because but but why we write that one? Because so we know that always total probability is always 1. Therefore, we write your suppose here x greater or equals to 4 that we find that value always we write what 1 minus your see that your x greater or equals to 4 is what 1 minus your 0 plus your 1 plus your 2 plus your 3. Okay, understand? Are you understand? Hello?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Understand the tree? What's the in case of probability? Remember that when greater than equals to the symbol arise, then what is it? You must have to the tree. Suppose 1 minus 2 of x,
Minus probability of yes, ma'am.
that one. Okay?
Mm.
Therefore,
Mm.
Okay, ma'am.
problem here suppose we are set to find the value of x greater or equals to 4. And in that problem, we have already find the value of x equals to 0, x equals to 1, x equals to 2, x equals to 3 also. Therefore, because we have already find that value, therefore, to get the value of this one, v of x greater or equals to 4, what we did, just 1 subtract all the values of 1 from 1. Okay. And otherwise, it should be what? It will be e greater or equals to 4 means what? It starts from 4. Start from 4, 5, 6, 7, 8, and it is not possible to find all the values. Okay? Therefore, there is a easy trick. We have already find the value of 1, 2, 3, and 4. Therefore, to find that one, just subtract the values of 0, 1, 2, 3. First, you have to add all the values of 0, 1, and 4, and after that, subtract the values from 1. Then you can get the value of your x greater or equal to. Okay. This is also another problem. In this problem, suppose if a random variable x follows a Poisson distribution, suppose this condition p of x equals to 2 into 9 into p of x equals to 4 plus 9 into p of x. Find mean and variance of x. Find mean and variance of x. And we know that mean and variance of Poisson distribution is what? M. Is that same? Okay. Remember this mean and variance of Poisson distribution is same. M. And but in case of binomial distribution, mean is what? NP, and variance is what? NP. Okay. Here M is what? M is what? Nothing but the product of N and P. And here we just use the formula of EMF of Poisson. Therefore, this we already know that the P of x plus r is what? Sigma minus m x r divided by r. And we are given this condition P of x equals to 2. Thus, the value of r equals to 2, and r equals to 4, and after putting this value, you get a equation like that one. After solving, that will be get suppose and this one. And here suppose there's first condition that first is what? M square plus 4 into m square minus 1. We write suppose m square plus 4 equals to 0. Then from this one it will be what? M square equals to minus m square equals to minus 4. That is what? This will be m equals to plus minus twice side. The complex number. But here this is not used. Here m is what? M is the parameter. Parameter is not complex number for the probability distribution. It's a real number. Okay. The finite number is a real number. Therefore, m does not equal to twice. Okay. Therefore, we cannot take this portion. Y equals to 4 equals to 4 plus 4 equals to 0. We cannot cannot take this part. Therefore, if the value of this m must be take m square minus 1 equals to 0. This is not possible. X square plus 4 equals to 0. It is not, because m is always greater than 0. So this m is always positive. The parameter is always positive. Therefore, this is not actually m square plus 4 equals to 0. It is not actually come. Therefore, m is what? M is 1. M means what? Mean and variance. Mean and variance are same. Therefore, it will be what? 1. Okay. Okay then. Conclusion is what? In conclusion for this class is what? Today we know that mean and variance of Poisson distribution. Okay. First, we discuss about mean and variance of Poisson distribution, and what is it? And mean and variance of Poisson distribution is same. It is m, a parameter. And second one is what? We discuss about the recurrence formula of Poisson distribution. And recurrence formula is what? Recurrence formula is nothing but it is the formula which is used to find the value of x equals to 1. So, suppose you are given x equals to 0, you can formula, you can easily find the value. Okay? Okay, then let me stop.
Okay, thank you, ma'am.